So in this exercise, the number 1 part 2, we are going at first doing the diagram, calculating the vectors and the tension for TD, TB, and TC. So after to draw the diagram, we calculate the trigonometric function because we are going to use all of these. So I calculate before for my equations. And then after doing this, we're going to calculate the balancing in each component. So at first time, we calculate the balancing in the component X. So I base for the diagram and use this balancing commune. And then I got the spatial. I got TB, as you can see. So I'm going to do this for the component in theta and the component y, because there are different ways to solve it, but one of them is by matrix, and I say, oh my gosh, I'm too chiquito for doing this, so I choose this form for doing this because I think this more easily. So now I calculate in components y that is different because we sum the different components that I got before, and then we're going to calculate TD by this equation. And usually we can do is to substitute the letter TD that we got balancing the rest components, and usually to calculate TD solving this equation. So after this calculating this equation, I got the tension in newtons, and after this I calculate the angle. For calculating the angle, I think it's easy. Before I calculate the substitution for TD, I'm usually do an operation substitution TD in the rest of the balancing forms, and then I calculate the angle, and I use this form for calculate the force in P.
Hi, my name is Eduardo, and I'm going to talk about the second problem of part 2. And it reads as follows. A portion of a mechanical coin sorter works as follows. Pennies and dimes roll down the 20-degree incline, the last triangular portion of which pivots freely about a horizontal axis through O. Dimes are light enough, 2.28 grams each, so that the triangular portion remains stationary, and the dimes roll into the right collection column. Pennies, on the other hand, are heavy enough, 3.06 grams each, so that the triangular portion pivots clockwise, and the pennies roll into the left collection column. Determine the moment about O of the weight of the penny with S equals 9.05 millimeters with 3 different methods. Finding A. Perpendicular distance to the force line action. B. The components of the force. And C. The cross product of R and F. As you can see, this is the diagram that we're gonna use. There's a coin here, and these are the pennies and the dimes. We have all the information in this diagram. Also, we have all the information in the text. If you read carefully, you're gonna have a good time. You're not gonna fail, and you can understand everything if you read correctly. So, grabbing all the information, I made my free body diagrams right here. They're all here, as you can see. They look the same, but they're not the same because they have different information. So let's begin with A. Okay, so with the first one, we need to find the perpendicular distance to the force line action. Now, we need to find the force, which equals to the weight. Now, to find the weight, we're gonna have to do this. We're gonna have to grab the mass and gravity. We all know that gravity is 9.81 and the mass, we have it in the text. It's 3.06 grams. So instead of using grams, we're gonna use kilograms. So we changed the grams to kilograms, which is 0.00306. We multiply that with the gravity measure, which is 9.81, and we're gonna keep that. We're gonna keep this right here. Now the next step is finding D1. Okay, so we're gonna grab 9.05, which is in the text, is the S part. In the diagram, it's this little part right here. (9.05) cosine of 20 degrees. 20 degrees is also in the text, and it's right here. It's right here, and we can use it to know that these are 20 degrees. So plus 13 sine of 20 degrees. Can change something right here. 20 degrees. There we go. Now we use the problem that we had here. We put it right here, and we multiply it by the same thing that we had here. Now you do all of this, and the result is this. Of course, you can round it up to, okay, it says 0.3887. That's what my calculator said. And you can round it up to 0.839. And this, in newtons, this is your force in newtons. I forgot to add in newtons. There we go. This is the force in newtons. So let's move on with the B. Again, using the same free body diagrams that I have here. We're using all this information to our advantage. Now B, we're gonna use the same. Force equals weight. Weight equals mass, and we multiply it by gravity. We have the same 0.00306, and we multiply it by 9.81. We have force 1 equals force cosine of 20 degrees, which is right here. It's tiny, but you can see it. And F2 equals F sine of 70 degrees. Why 70? Because we need to round it up to 90 degrees. Now, this equals to F LS by S. Now, we're gonna grab the information that we have here. I'm gonna put it right here. We're gonna multiply that by cosine by 9.05. That is gonna give us 0.25. It's in green, so I'm gonna just write it over. 0.25. Now, the second one in D, we have to find D. We're gonna use the same thing, but now with cosine of 70 degrees by 13. And that gives us 0.13. We sum the numbers, and it's 0.38. But wait a minute. We have to do all of this. So it's our real number is 0.3887. That's what my calculator said with all the problems here. But of course you can round it up to 0.39. It's the same. Now, sadly enough, I couldn't understand the C part. This was a pain in my head. I couldn't understand it. I'm very chiquito. I couldn't understand it. And well, I'm really sorry for it. I'm really sorry. I couldn't do it. It was too difficult for me. But the two first parts, A and B, are done and 100% corrected, and I was like meticulous about it, and that's it. Thank you for watching. So an update from my last video. So we need to to find the cross product of R and F, this right here. We need to find them. So this is how you find them. You're gonna have to do this with this and do a matrix right here. We're gonna have to do an inverse matrix so that it's gonna be something like this. So we put this, we're taking in account the products of the matrix right here. We are dividing them in 3 different ones. So we put 0 here, minus b, 0. Repeat. I will repeat it. It's all within the products of this matrix. We are just separating the I, the j, and the k, with each one being an individual matrix. So it's gonna be more easier for us to take the results from them. So this we're gonna rest. We're gonna minus j, which is this one right here, s 0 a 0, plus k, which is this one right here, s 12.55 a minus b. So we do all of this, all of this, it's gonna be this result. Minus, this is I, this is the I, this is right here, this is it. It's not an arrow, it's an I. I want to put it right here so you can see it. It's an I with a Chinese hat. That's what I call it, Chinese hat. Minus 0, j with the Chinese hat, plus k, and we grab s, we multiply it with minus b, and we subtract 12.55 a. We multiply these two, and it's gonna be something like this. Our final result x, it's gonna be 0 0 minus 9.05 sine not sine, x. Okay, we're taking in mind that this x is gonna be these 2 problems right here. Just because I'm saving space because I don't have a lot of papers, I'm gonna be that x, double x is gonna be this little problem right here, just to save space, So minus 9.05 double x, which is that problem right here. That problem is 0.00306 multiplied by 9.81. It's been said before, it's the same. So double x, sine of 70 degrees, minus 12.55, which is right here, double x. It's okay. So to better understand this, is this number minus 12.55 is going to be multiplied by all of this. So let's continue. Cosine of 70 degrees. So our final, with using the calculator and doing all of this, which is 0 0 minus 9.05 double x, which is all of this, sine of 70. Of course this is just one big problem right here, one big that we need to do, minus all of this, 12.55 multiplied by 0.00306 multiplied by 9.81. You get it, right? Cosine of 70 degrees. Now, all of this with this is gonna give us, it's gonna put it right here, 0, 0, minus 0.3038. And that's it. That's our final result. Of course, it's a large number, but you can round it up. That's it. Thank you.
Good night, Professor. I'm going to present exercise number 2 for physics. I'm translating this for my partner, so my partner do the exercise, and me, I just only put the voice in English. So after read all the problem, we saw the diagram, and that says that the letter I represent the 4. Point G is the center of the mass for this object. The line between the 12 and 14 up down for letter G, it's represent the center of the wheelbarrow. Sorry. After to analyze this picture, we're going to draw the diagram for us that my partner draw for a rectangle triangle using the data given for the problem. Important to say that this picture of this triangle is in phase 4 to point A. Now that letter P is the force that the person are exerting in the wheelbarrow, and that force is inclined, or the inclination is given by 60 degrees. The weight of or the mass for a certain point is given by 200 libras. So for found the magnitude for is for point A to for the point 4 is going for the P, and have a degree for the inclination for 70 degrees. This is the next my partner got it for Pythagoras, as we can see. 46, that is the distance, and plus 14 both to the square, and we solve this, and we got that letter B is given by 34 squared number 2 root sorry. It's important to know that letter A prime, we don't have the value. It equals to 0. We now to calculate the summatory of A, that is our point, that is the wheel for the wheelbarrow. We can say that the 22 LV for 10 times 10 minus A prime minus 22, as you can see in the equation. Sum up, we use that equation that is given us by my partner, and finally we got that P is equal to 52.832 LV. So we got the summatory for force 8 is equal to 0, and we got the force P, that is the force that are applying for the person. So now for the next question, we have to calculate the minimum P for this problem. We use 90 degrees, as we can see, for get the minimum P, or the minimum magnitude P. And usually use this formula, 2200 divided by 34 root 2 sin 90, and we got that PM it's 45.7541 LV. So it's only a formula to use using the 90 degrees for the angle. So we can see the final results. The magnitude P with an angle of 60 degrees is equal or similar to 52.832 lV. And the angle makes the minimum magnitude of P force is 90 degrees with magnitude of 45.75 for LV.